hear me, everyone? If there is any problem, immediately let me know. So in case I get disconnected, you can wait. I will go sometimes different internet problems that this power problems. So if there is any problem, uh, you can let me know. If I'm not, that is if I got log out, that is, then wait in the room, that is, I will join in case there is some problem. All right. Yes, some people are raising hands. You can type the question, or you can speak and tell, but sometimes I have to mute it because some people start shouting unnecessarily. Uh, all right. So everyone can hear me, no? Right? Everything good?
Yes.
Okay, great. Okay, so I remember last time now, yesterday we did the lecture on vectors and how the applications of that, unit vectors, those things. But there are some tutorial classes that, tutorial discussion classes or lectures that we have to cover, because this is also directly part of the lecture. So uh, there is no any uh, other tutorial class unless there was some arrangement. So this is also part of the lecture. So it is also I take as discussion lectures. Uh, so here we did problems up to in tutorial 6. You also can open your one if you like. Yeah, all the tutorials has been that given for marking. Um, and here we did up to problem number 3. Tutorial number 6. So the remaining problems we can discuss. All right. Here these ones we did. That is taking derivatives and finding the angular velocity and those things. Angular acceleration. Those things we did. And yeah, problem number 4. You can read the question and remind yourself. So this is supposed to be a discussion kind of thing. So you can discuss the stuff to eliminate your doubts about any this stuff. Yeah, there are some. Yeah, if someone wants to speak, they can explicitly ask to unmute. That is, else sometimes there are disturbances. That's why I mute your microphones. All right. In the meantime, you can type the chat box if you have any, that is, you want to talk, or you have some problem. Yeah, problem tutorial number 6, problem number 4, because this one we did last time, problem 3, right? Uh, so calculate the rotational inertia of a meter stick with a mass of 0.56 kilograms about an axis perpendicular to the stick and located at 20 centimeter mark, right? So you know that what is inertia, how to calculate it, because we can assume that the meter stick is a thin, that is, you can treat the meter stick as a thin rod. And you know the inertia at the center of mass for such a thin rod. Anyone remember the value? Yeah, that's one usually in exams we give, but these things maybe you've done so many times you have to easily remember. at the center of mass, um, the inertia of the meter stick is, you can check it up. For a thin, if you assume it's a thin rod, it is 1/12 ml squared, right? Where M is the mass, L is the length of the meter stick. So this is the center of mass value, but it is asking not at the center of mass, but about the axis perpendicular to the meter stick uh, located at the 20 centimeter mark. So you can imagine a meter stick and imagine the 20 centimeter mark in your head. You have used that meter sticks in the lab, right? So where is the center of mass? Which where is the center of mass of the meter stick located? At which distance? So anyone? Can you type it in? Or you can, yeah, speak also. There, I made it unmute, so you can speak and tell also. So your meter stick, it is at the 50 centimeter mark, right? The center of mass or the balance point, some people call it, is at the 50 centimeter. That is here, right? This one. Yeah, some student, half of stick here. That is correct. In other words, it's at the 50 centimeter mark. Uh, so you to find that 20 centimeter, what theorem should you use? Anyone? Which theorem? I know the center that is 50 centimeter, that is the center of mass value. It is 1/12th. And but it is asking not at the center of mass, it is asking at 20 centimeter mark. So you have to use the so-called parallel axis theorem. So these things you have to know very well because you are doing a university degree and it is engineering technology. If it is some other thing like poems and that and this, maybe you can skip many things, right? These ones uh, is you have to be very interested in what you learn because this is engineering. So make sure you understand and what is parallel axis theorem and when to apply it. Especially the application side is expected from technology students. So how to apply a theorem like those things. So you have to make your notes by yourself. I think if that is the way you learn, some short notes, and or otherwise you have to somehow understand the stuff and learn it. So here I put the parallel axis theorem and the distance from the center of mass, I take h. So if it is 20 centimeter mark and the distance from center of mass is h, because the parallel axis theorem is I equal I center of mass plus mh squared, where h is the distance to the point of concern from the center of mass. So, so if the 20 centimeter mark is the point of concern, what is the distance from the center of mass? H. What is H? Because the center of mass is located at the 50 centimeter. So we are concerned about the 20 centimeter mark. So the distance H is 30 centimeters, or in meters, 0.3 meters. And you put that here, this equation, because the M you can take it out of the parenthesis. And you just have to put the mass of the meter ruler. 1/12 is the center of mass value. and the distance here, h, so becomes 30 centimeters. And the inertia you can calculate as this value. Any questions there? So if someone doesn't understand the basics, that is the fundamentals, there's this huge problem, because that is not good. Without understanding the fundamentals, one cannot proceed in engineering, technology, or even science. So make sure you understand. So this is the chance I give you to discuss. You can speak and discuss or type it in also. And additionally, you can talk to the demonstrators also. If you want some additional classes, uh, some arrangements can be made. You can uh, discuss with them and see what can be done. So make sure you like crystal clear, understand everything, right? All right. And the part two of that question, you can read the question. Right? I think you are seeing the question, right? So tutorial number 6, we are discussing, if someone joined a bit late, problem number 4, part 2. So can you read the question here? So trucks can be run on energy stored in a rotating flywheel with an electric motor getting the flywheel up. So its top speed is this. Suppose that one such flywheel is a solid uniform cylinder with a mass of 500 kilograms. So it's pretty heavy, 500 kilograms, and radius is 1 meter. So it's quite large wheel. Um, so it is rotated using some electric motor. What is the kinetic energy of the flywheel after uh, charging? So which kind of motion the flywheel experiences? Is it translational motion? It is linear motion or rotational motion? It is rotational motion. So for the rotational motion, you know the kinetic energy can be written like this: K equal half I omega square. So these things you have to remember. That as I told, these are the fundamentals. It's like a foundation parts of a building. If there is no foundation, there cannot be a building, right? Do you understand what I mean? They are the fundamentals. Without the foundation or frame of a something, of a car or something, it will not exist. Um, so, and also you have to enjoy this. That is, you have to feel that you are learning because, not because you are going to just pass the exam, but you are someday you will use the knowledge actively uh, in some maybe industry or maybe academic, or who knows, right? But many Sri Lankan students think differently. They think, okay, this is just another O level or A level, uh, and yeah, just another such a thing, right? That is not the way. So that's, I think, one reason that the education system has failed in Sri Lanka. It is like failed drastically. So you are the future of the country, and hopefully at least one or two is understanding what I am telling, right? At least. if everyone understands, pretty good. And yeah, so this is the kinetic energy, and I is the inertia, omega is the angular velocity, or in this case, we will say it is the angular speed because we are only considering the magnitude. And for the like wheel, a flywheel, it's something like this, right? Like a disc. So the inertia is given by this equation. You can look it up on the textbooks also. So instead of the inertia, I put this, and I calculate my kinetic energy. But here, this is rotational kinetic energy. The energy is coming because of the kinetic motion, but it is rotational motion of the flywheel. Also, there are such things that they are in, maybe when you were small, you had a toy, some car or something. Such toys are made using such a flywheel. Like you just rub it on the floor and you just release it, and that toy car moves because of the energy stored in the flywheel of that toy. So this is mechanical energy. This is completely mechanical energy stored in a flywheel, right? And so you put the numbers and you can calculate that. What is that energy? So one student has typed given or not. Yeah, inertia usually value is given. Usually given. Usually in exams it's given. But it is not much. We are currently working on rods and cylinders. So it is either 1/12 or 1/2 most of the time. But of course, there can be other versions. All right, that is at the center of mass. But here, we don't want to use the parallel axis theorem because, can someone tell me? Because this is the inertia at the center of mass. And usually the flywheel rotates, it says rotates around the center of the wheel. So we don't have to again use the, uh, that is parallel axis theorem because we are at the center of mass. Any questions? Other questions? All right. Okay, next question, problem number 5. Uh, can you read it and remind yourself? So if you have a paper, you can draw a sketch and try to actively participate in this year. This has to be active lecture rather than, because it's a discussion kind of thing. So everyone can see the question. A thin rod of 0.7 and also you have to register with, that is you are logging with your TG number as your name, else I am unable to, that is easily identify who you are. Yes, some students join in a group. If you are joining a group, put all your TG numbers, uh, names not necessary, only the TG numbers as your name. When you log into, if you are already logged in, you can also modify that. You can change your name by right clicking, I think. A thin rod of length 0.75 meters and mass 0.42 kilograms is suspended freely from one end. So again, a thin rod, maybe a meter rule, but shorter. So it is not necessarily a meat ruler. So a thin rod of length 0.75 meters has a mass of 0.02 kilograms, is suspended freely from one end. Here it is something like this, suspended freely from one end, and it is pulled to one side and then allowed to swing like a pendulum. So here it is maybe initially like this. So it is suspended at one of its ends like this, like a pendulum, and it is pulled to one side like this and released. All right. Allowed to swing like a pendulum, passing through its lowest position with angular speed. So when it passes through its lowest position, the angular speed is given as here 4 radians per second. That is omega is given. Neglecting friction and air resistance, find the rod's kinetic energy at its lowest position. And the part B, it says how far above that position the center of mass rises. So you know, for a rod, the center of mass is at the middle. And first question, it is asking for the kinetic energy, but you know the kinetic energy is given by, because here, first thing you have to identify is this is rotational motion, not just linear translational motion. So the kinetic energy is given by this equation rather than the half mv square, because there are many masses, because this is not just a point particle. So you use this equation, but here there is an I that you have to use. But here you cannot use the center of mass value, because the axis of rotation is, in this case, not like in the flywheel, the axis of rotation, because it is suspended at one of the ends, hang from one of the ends. Then you cannot use the center of mass value. Here you have to use that parallel axis theorem and find the value at the rotational axis, which is at one of the end of the rod. And so the parallel axis theorem, you know that I equal I center of mass plus mh squared, where h is the distance to the suspension point. All right. All right. And you put these things because again for the thin rod, the standard value is half ml squared at the center of mass, the inertia. And h here is how much? If the length of the rod is L, what is h? L over 2, right? Because this is the center of mass, it is suspended here, one of the ends. So if the total length of the rod is L, this is L over 2. So if I use h equal L over 2, here I can write like this. And once I solve it, I get something like this. All right. Any questions? So this is the inertia value you should use when calculating the this kinetic energy of the rod. So that value I put here, not 1/12, 1/3. So it is larger than 1/12 because it is more difficult to rotate this rod at one of the ends compared to one of that is at the center. That's the center of mass. And you put the numbers and you get the kinetic energy. So simple and sweet. So I hope everyone understands. So don't be silent. If you have any questions, you can uh, turn on your mic or you can type it in the chat box. Right? So this is again the kinetic energy, which is the energy coming from the motion of the particles, because kinetic energy is a energy related to the motion. But here it is rotational motion rather than translational motion, right? So one student has put a question. Reference distance එක ගන්න ඕන නැති scale එකක් හොයන නිසා. So you have to type your question in English because our medium of communication is officially English, right? Because this one, I even don't know what you are telling. Yeah, you can type it in Sinhala, but better to type it in English. ගන්න scale එකක් හොයන නිසා. I think I know what he's asking. He's asking about the reference distance. Yeah, we will come to that. We will come to that. We are not using any scale here. That is reference distance actually comes for that is potential energy rather than kinetic energy, right? Reference reference come for potential, not kinetic. Not because we are not taking any scale, but this is kinetic energy. But when we come to potential energy, in the part B, we have to use it. There we use the reference level. Don't confuse potential energy with kinetic energy. Kinetic energy comes because of the motion of the particles or particle. Kinetic, kinetic energy comes from the potential energy comes because of the location of the particles. So to say, that is right, potential energy. That's why we use a reference, especially in the gravitational potential energy. Right? And part B, one is energy because of the motion, which is kinetic energy. Potential energy is because of the location of the particle. All right. In this part here we are talking about rigid bodies, and so it's not just a part. So but we can assume that all the mass is concentrated at the center of mass, and apply the conservation of mechanical energy in order to, because in the part B it is asking what is the, how far above the center of mass would it rise. So you know the speed at the lowest point. So how much it rises depends upon the conservation of energy. That is basically what happens is, the energy converts into from one form to another form. Right? Like kinetic to potential. Like, so you know that the conservation of energy equation. So in order to find how far it rises after going through the lowest point, I can draw my sketch, and I take my initial point here. But that is, since it is a rigid body rather than a point particle, I choose my center of mass and as my initial point, final point, also again center of mass, but it is at a higher point. And I apply the conservation of mechanical energy. Earlier you did this for like a simple pendulum like configuration, right? So here now you are doing it for rigid bodies, uh, not just a single particle like in a simple pendulum. Right? So in this case, you have to consider the center of mass and apply the. So you remember that this is the. This means the final mechanical energy equal the. But mechanical that is final mechanical energy equal initial mechanical energy. I just put MF, that is mechanical energy final, equal mechanical energy initial. And you have this equation because the mechanical energy is made of two energies, which is the kinetic energy and the potential energy. So these things you have to know. All right. So this equation, I think you already know very well. When acting kinetic energy, why potential energy not zero? One student is asking. I'm not sure what he is asking. You have to be most clear about your question. What exactly are you asking? Why kinetic energy not V0? Why potential energy? Why potential energy not V0? Yeah, potential energy doesn't have to be zero, right? Neither the kinetic. But potential energy, since we are here considering the gravitational potential energy, not only can it be zero, it can also be negative because it is given by mgh. Remember, zero is the difference. It can also be negative. Because one might ask how the energy can be negative, right? Because gravitational potential energy is relative to some reference level. It, gravitational potential energy not only can be even uh, negative, as I told, because it is relative to some reference point. You can arbitrarily choose your reference level, right? So here I will choose my reference level as usual. For pendulums, I choose it at my suspension point. That is so, this is arbitrary. I like the suspension point for pendulums. But some people may like the flow level for pendulums, especially the science people. They most of the time at the ground level. But engineering people, a little bit more, maybe advanced. I'm just saying. Okay. And technology. Yeah, technology. All right. And physics people, they are, yeah, they are like more advanced. But basic science like Montessori level, maybe everyone at the ground level. All right. And here I choose this as my level, like in the regular, remember in simple pendulums, um, you choose it. All right. All right. And but now this is not a simple pendulum, but similar, you assume the mass is located at the center of mass. And I similar my regular reference level for pendulums, including simple pendulums. I choose at the suspension level and I apply the equations. So you know that the gravitational potential is given by mgy. So this you can put there because the kinetic energy, final kinetic energy, what is the, because when this rod comes to the highest point, what is the speed of the rod? Angular speed? Anyone?
Zero.
Zero, yes, it's zero. So you put zero for the kf, and uf you put the potential, final potential. So um, if I take the distance from the center of mass h, the height climbed to be h, then I can put that distance because when I take this to be my initial level, all my gravitational potentials are negative. So because the y is negative, because it is below the reference level that I choose. But if you like, you can choose other levels, including the center of mass level as your reference level. I propose you to try that also. That is, instead of choosing this level as your reference, the gravitational potential reference level, that is y equals 0 level, you can choose the center of mass level also. And since the y is negative, you see that the y height is, because this total height is L over 2 minus this height I take h, that is how far the center of mass is from h. Then this is the mg y, and this side, you know, we already calculated the initial kinetic energy, and you put the initial potential energy minus L over 2, because if I choose here this as my suspension level as my reference level, then my initial height in the potential y is minus L over 2. But if you choose this as your, that is your center of mass initial level as your, this dotted line as your reference level, then this would have been how much? Would have been 0. But here also you see the minus L over 2, minus L over 2 cancel, and so you have to do it by yourself and experience the problem. You have to feel the problem. It's not just by hearting some equations. You have to do it by yourself, like learning to drive a car or motorbike or whatever, your bicycle even. You have to do it by yourself and you have to feel the problem. Else it is just like looking at someone else driving a car or motorbike or whatever vehicle, or even a bicycle, and you think that you can do it. But when you go to the exam, you find out that you sometimes you can't do it because you didn't do it by yourself, right? Yeah, sometimes you will make mistakes, sometimes, but don't just assume that listening to something will make you a graduate. Maybe in the A level, but definitely not in the units. You have to work hard and learn. That is because Sri Lanka, everything free education, that is free, this is free. So people have no this feeling about this. They don't feel it because they have no pain on this. No. Even the learning process, that is the problem, unfortunately. So most of the time, the student just assumes that they have learned. So that's not good. You have to try it by yourself, try different methods, and argue with your teachers also. If how can this be? Is it correct if I do it like this, like that? right? But in Sri Lanka, most of the time, university education is, yes, totally, yeah, I wouldn't say useless, but yeah, very, very strange compared to the international standards. But yeah, maybe in the future you will understand what I'm trying to say, and maybe you will be able to change. It's not easy because it's very complicated. But what I'm telling is that you have to do give some effort, and you have to try the problem, try different methods, change the reference level, right? And try it by yourself and feel the problem. Unless you feel the problem, you will never learn. Even in the art faculty, like if you are doing some dancing, someone you look at someone else dancing, no use, right? You have to dance and learn that, right? Even singing, like, right? Even in any discipline, this is the case. But unfortunately, yeah, I think that students have confused. University is a place where that they just come and stay, and after 4 years they are given a certificate for just coming there, something like. And after getting the certificate, someone has to give them a job. So that is completely wrong thinking. Because of their degree certificate, someone doesn't have to give a job, right? They should have the skill set. To get the skill set, you have to solve the problems by yourself and see how to solve it in a different method, for example, and learn. Teaching is one thing, learning is another thing. Learning should be done by you, right? So you have to practice, not by heart. By heart may work in some disciplines, but in engineering technology, that will not work for everything. That is some things it might work, right? Any questions here? So you put the numbers here and you solve it and you find the h height. So I would say you choose the reference level at the center of mass here, initial level, and see if you get the same answer. That is additional exercise. So those are very important things. Here I put the note also. Solve a problem by, you may also solve the problem by selecting the initial level. Yeah, the initial level, that is this level, as your reference level. Then it might be a little bit easy, but since I want to keep everything in the general format, I choose it here, right? Even in the simple pendulum problem, you can choose the initial, yeah, I level as your initial level. That is your reference level. We did such examples. You can check the notes, right? Discussion notes. And problem number 6. Problem number 6, can you read it? And remind yourself. So even for the end semester exams, you have to practice by yourself and learn. Not that is assume that you have already learned, because the more you learn, the more you try, the more you learn by yourself. Same principle as you are trying to learn to drive a vehicle. You have to do it by yourself, else you will not get the skills. When to change the gear, when to press the brakes, right? Like that. So currently you are just looking at someone driving the problems, but unless you drive by yourself and learn how to do it, you will not learn. So yeah, there is a lot of work there. That's why we call it education university. Um, like everything is the education may be free, but doesn't mean that is you don't have to learn anything. Everything will be automatically uploaded to your brain, so something like that. No, that is not free. All right. So here you can read the question number 6. So if you have any problems, even the previous ones, you can ask me, right? And if you have further problems, you can also discuss with your, that is, discuss with the demonstrators also, tutorial demonstrators. So it is that in, we say sometimes, sometimes that is, it is your move in some games that we say that this is a two-part process, right? But it is up to you if you don't want to learn, and that is, no one is going to shoot you or anything like that. Like maybe scold you or like in a school. Because this is university, you assume your brains have developed to such a level that you understand why you are doing something. Right. Uh, and here, problem number 6. Uniform cylinder of radius 10, that radius 10 centimeter and mass 20 kilograms is mounted so as to rotate freely about a horizontal axis that is parallel to and 5 centimeter from the central longitudinal axis. So this is a cylinder. The radius is given, mass is given. So it is allowed to rotate freely about a horizontal axis that is parallel to its central axis. Now, yeah, this is like that flywheel, not exactly like the flywheel because now your rotational axis is shifted. It's not at the center. It is 5 centimeters from the center of the cylinder or disc. Um, so yeah, here is the suspension point. So initially, so this is the center of mass. So what will happen is when you suspend from this point and release it, it will fall down. This, right? The center of mass will come uh, to the lower position. So question is asking what is the rotational inertia of the cylinder about the rotational axis. So rotational axis is now, so the cylinder also like a disc. So again, it is 1/2 mr squared. So you can use it. And but here now you cannot use that is not the inertia at the suspension point because now it is suspended off axis. So, but the axes are parallel. Uh, so you can use the again uh, the parallel axis theorem. I equal I com plus mh squared. This one. And but for the cylinder at the center of mass, that is this center point, you know it is same for the disk, half m r square. Yeah, I missed the mass of the disk. R is the radius of the disk. And yeah, once you put the numbers, you will get inertia this much. But h here is how much? Can someone tell me what is the value of h? Yeah, it is given here, 5 centimeters. but you put it in meters, right? So if you don't understand these things yet, as repeatedly telling you, you have to do it again and again. For example, if you can't drive a drive a motorbike, you have to do it again and again. Even you fall or not, can't help. All right. So here you have to drive the problems. That is, you have to do the problem by yourself and learn. So unless you do that, you will never learn. Coming to a lecture doesn't mean not coming to a lecture is even worse. That I understand. Even I think you understand, but coming to a lecture and listening to something also doesn't necessarily mean that you have learned. To get a skill, you have to do it by yourself. For example, to cook something, like unless you go to the kitchen and try that, no one will learn, right? That is, they can look at the menu and that is the item list. You have to put this much of pepper and this much of chilies and you put some more this water this much. But unless you go and do it by yourself, it is not, you will not get the skill set. So here you are getting the skills for solving engineering problems. So these are the fundamentals. Because a technologist or engineer, usually what they do is solve problems. One of the objectives of uh, uh, their work job. So solve different problems. In your case, maybe maintenance stuff also. So how can you maintain some thing, instrument or device or machine or without understanding the fundamentals? At least let let go the advanced stuff, right? So make sure you put some effort to it. That's what I'm telling. Don't assume that you have learned by just listening or by looking at some. One student is asking, this problem uses half radius of H. No. Yeah, that's Buddha. That's why I'm telling you have to do it by yourself. So that's why we give tutorials to you so that you try it. But most of the time, what happens is few people do it, other people just copy it from that or from somewhere. Oh, yeah, that is the thing. So it is half of it, but it is just a coincidence because it says it is 5 centimeter from the central. So central longitudinal axis, the center of mass. So the suspension axis is located 5 centimeter. So yeah, it coincidentally became half, but that is nothing to do with uh, that is half is just a coincidence. So that's why I'm telling, unless you try it and you try to learn by yourself and or in a group, or at least try to teach some people, you will not learn. One way of learning is that you can teach some group of people. Then you will feel the problems, right? All right. And part B, part B, it is asking if the cylinder is released from rest from the central longitudinal axis as the same height. So if you release something like this, what is the speed of the cylinder as it passes through the lowest point? Angular speed. So it is kind of similar to the previous problem, but now instead of a rod, you have a cylinder or a disc, because the length of the cylinder is not a concern in this. You can assume it to be a disc. And here you could apply the conservation of energy in order to find the angular speed. So it falls down. So you again put this conservation of mechanical energy, and you assume the total mass is located at the center of mass. So it is, in this case, the center of the disk, the black dot. So initial point I take here, final here, H, this one. And I put the equations. But now, yeah, I have to put, so it is asking what is the final angular speed. So because the final kinetic energy given by this equation, half I omega F squared, final potential energy. But here also I clearly mark my reference level. So again, I take my suspension point because this is also kind of like pendulum. And yeah, the final potential energy. So again, I measure my heights for the potential energy from my reference level. That is the suspension point. And so if the lowest point is, yeah, the lowest point is here. And so the H, already you know H is 5 centimeters. You put it, but again, this is the point here is located below the reference level. So it's minus H, the YF, and you get this. And omega I, initial, it is released from rest. So initial angular speed is 0. And I can take my initial potential energy, how much? 0, because initial point also on my reference level. So initial height is 0, yi is 0. And I get this equation. Because the right side all becomes 0, I take this side and this equation, and I put the numbers, and I can find the final angular speed. So the units are also something that you have to be concerned. Since all the meter stuff get cancelled, you get it in radians per second. So do you have any questions there? No questions, right? So as I told again, if you don't understand, but here this reference level is the same. So yeah, this statement really doesn't count. So I can remove that because the initial level and my reference level both. All right. But for the previous problem, that is true. And do you have any questions here? So as I told, it's up to you to learn or not to learn. Free education doesn't mean knowledge is automatically freely transferred. It's up to you to get it or not. There is no free transfer. Education is free, but transfer is up to you. That is, you get the skills because you need it. Because you are assumed to be adults and understand why you are learning. And yeah, transfer is up to you. Right? So make sure you get the skills. Okay, so I'll finish. This one is done. I already put this on, I think, TechMIS. No, that is LMS. We will go to the next tutorial. Maybe we have about 30 minutes or more. So do it by yourself, and it's up to you to learn. No one can point a gun at your head and ask you to learn. Right? So it's up to you to learn. Okay, let's go to the next tutorial. All right, give me a second. Now was it tutorial number 7, right? Yeah. Also, I will now, after the class, I will put it on to the LMS. That one also you can learn. So, Tut 7. Oh, there it is. At last. Tut 7. 200 and, yeah, Tut 7. Tut 7. Okay, I think you can see the tutorial. Ah, yeah, it shows my screen share also. Yeah, this Zoom has been improved a lot after those COVID times. Oh, yes. Yeah, it has so many facilities now. I can see if you are seeing the screen or not using the Zoom. So currently you are seeing my screen, tutorial 7. Yeah, that is the next tutorial. So you can remind yourself the questions. So it is to do with now previous one, your rotational stuff. Now this is further continuation of rotational things, but on the dynamics. To learn about the torque and how to apply the torque, those things in the Newton's second law, right? So here you can read the question and remind yourself. So if you have a note, you can notebook or something, you can draw some things. The length of a bicycle pedal arm is this much, 0.152 meters, and the downward force on the bicycle. So this is directly mechanical because a bicycle is a mechanical uh, this machine, right? Anyone ride a bicycle? Yeah, that is the thing. If you at least seen a bicycle, so the bicycle, the first year, the engineers built it. Yeah, they made it, and now in the future, maybe the bicycle is still not maybe the best way, right? But the technology has advanced so much. Now even there are flying vehicles. You you can just go on the road and just make your car into a plane. So technology advanced, and there are such vehicles. Some there are like vehicles you can go on the water and also on the land, like that. But bicycle, the machine was a basic vehicle developed long time back. But that is one of the mechanical uh, machines. But in the future, maybe you will make more advanced machines, hopefully, right? But you have to understand the machine, how that machines work. Mechanics is about machines, right? Yeah, foreign, these people, yeah, they make a lot of things like bicycles and a new kind of bicycle. In some bicycles, the wheels are on top and the seat is in the bottom, like that are very strange technologies. Yeah, I just say, but in Sri Lanka, I don't know what they are doing. Just they are waiting till someone makes it so we can import it here. giving some dollars. And we call this is the free education, and be very proud about it. Yeah, someday you will understand what I'm telling, unless you have already understood. And okay, so that's just the introduction. Let's go to the questions. Problem number what? Tutorial 7, problem 1, part 1. That is sub problem 1. The length of a bicycle pedal arm is this much and the force is this much. It is asking what is the magnitude of the torque about the pedal arms pivot when the arm is at an angle 30, 90, and 180 degrees. So this is something to do with the torque. I'm not sure you have learned about the torque in A level, but even though the A level syllabus is so, yeah, it is like beyond the engineering level. But what have you learned is questionable. So many students, I think, not learn about the torque. I mean the torque, the this one, not yeah, yeah. So the torque you can calculate like this. So you learn the equation. So better to draw a sketch always when you do some problem, the schematic, uh, basic one. And here, this is the equation for the torque. Tau equal RF sine phi or sine theta. You remember, right? The equation. So the bicycle pedal, it has an arm. If you have seen a bicycle, basic machine, basic mechanics. Uh, and force is applied on the pedal. Think, just imagine you are applying the force on a bicycle pedal. Everyone can imagine it in their head. So the pedal is here. You put your foot and press it down. Then they start rotating round and round. And it is connected by a chain. And so it is rotational motion. Most of the stuff related to what we did, right? Uh, so if this angle is 30 degrees, then you know that sine, the angle between R and F is 30. Then you put those numbers here and you can calculate the torque. So not only a bicycle pedal has a torque, even the modern car, electric cars, or other cars, hybrids, or that is car with the combustion engine, uh, all produce torque. That's how the tire rotates. But different mechanical machines use different uh, these techniques to make the rotation. Bicycle uses the bicycle pedal. The combustion engine car uses pistons, right? And the electrical car may use motors. But everything produces a torque. Without the torque, you cannot do the work, right? Because something has to rotate. Right. This you understand this. Here you put 30 degrees. So part A is clear, right? Part B also similar, but 90 degrees. So the diagram becomes something like this because then it says the paddle arm is 90 degrees with the vertical. That means the vertical is the vertical. And now the force is here. Then you get the maximum torque. So at 90 degrees, sine 90 is 1, you get the maximum torque. And 180 means the lowest point. Your paddle has come to the lowest level. Just imagine the paddle in your hands and you are riding a bicycle, right? At the lowest level, so sine 180 is 0. So there is no torque at that point. So torque symbol, you use the tau, right? You know those things. We did all these things, right? Everyone understand that? Anyone don't understand? Raise your hand. No, no one raised their hand. Recognize. Yeah, you can raise your hand using Zoom. Oh yeah. And part two, this one, you have to like solve this problem, but we did this in the lecture notes also. So you can go through the lecture notes and see. Can you read the problem, that part two? So have your notebook or some papers and write something, just some sketches and some equations, not much of words, but maybe some words. So more your hand and the head, that is your brain cells, start activating, you will learn more. And in the part two, the figure to the right shows a uniform disc with mass 5 kilograms and radius 14 centimeters mounted on a fixed horizontal axis. So it's shown in the figure here. Mass is 5 kilograms, radius is 14 centimeters. So it is a little bit, that is a small disc. A block with mass m equal 2.5 kilograms hangs from the massless cord. Here, massless means hypothetically, assuming that the mass is very small of the cord, uh, because there are no massless cords in the real world, right? Means the mass of the cord may be like 1 gram or something, so it can be neglected. So the mass of the hanging block is 2.5 kilograms. Is wrapped around the rim of the disc. The cord does not slip, and there's no friction at the axle. So here we assume there's no friction at the axle. Here, that is also, that is, we assume the friction is negligible compared to the other forces. What are the acceleration of the falling block? So first question is, it's asking what is the acceleration of this block? The angular acceleration of the disk. So as I told, these things also you have to practice. Don't look at the answers and just try to answer the question again and again until you get the proper uh, skills. All right. First question is it is asking what is the acceleration of the falling block. Second question, the angular acceleration of the disk. What is the angular acceleration of the disk? The tension in the cord. Next thing is asking what is the tension in the cord. Right. So as in most of the problems, you have to again draw a sketch. Here, the sketches in these problems are called the free body diagram. So here there are actually how many bodies? One body is performing translational motion, other body is performing rotational motion, right? So how many bodies are there? Two bodies. Here, at least one student is catching up, I see. Maybe some. So if you don't understand, please try to ask some questions. So this is not two bodies, this is nobody or something like that even, right? Yeah. So yeah, so there are two bodies. One body is performing rotational motion. Other body is performing translational motion or linear uh, motion. So we can draw the sketch, that is the free body diagram for each body. One for the disk, one for the mass, hanging mass. Yeah, but here it became the same diagram, but you can draw it separately because they are two bodies. Uh, and uh, and next thing, you mark the forces on each body. So for the mass M, uh, so the tension. So in this problem, it's maybe better to draw the free body diagrams for each body in the same diagram because the tension, so you notice that the tension is the same because you assume that the string is massless. But if the string had a mass, the tension at the pulley or the disc and the mass would be different. But since we assume there's this massless string or negligible mass, the tension at this point and this point are both T. So you mark those things in your, even now you can just, for practice, just take a piece of paper and draw it and mark it. So as long as you don't move your hands, you will not learn. So in education, you move your hand by using a so-called device called a pen or pencil, and you have to use paper, and then only you will learn. Although that is the skills that you gain, right? All right, and you mark the forces, uh, and here on the M you have the T, simple M, hanging mass, and the mg or fg, the gravitational force, which you can mark as mg, and you mark the acceleration of that as a. And you can apply the Newton's second law for that mass. For each mass, you have to separately apply the Newton's second law in order to find the acceleration. So first I apply the Newton's second law, F equal ma or F net equal ma in the plus y direction. I am applying it in the upward direction. So my acceleration I mark downward because it is usually pull downward. This cannot go upward because there's no other upward, any other upward force. So this becomes negative, acceleration negative a. So the downward force is mg, but the upward you have the t and the minus mg because I'm applying this in the plus y direction, that is the upward direction. But also you can apply it in downward direction if you like, right? So that's why I'm telling there's no, you cannot by heart equations. You can't by heart mathematics. You have to get the skills of solving that. So engineering is solving problems using mathematics. So if you don't get the skill by yourself, then you will not be an engineer, no, technologist, or uh, whatever your degrees, engineering technologies. And and for this rotating mass, you have to apply this equation, which is the rotational version of the Newton's second law. And you put the number, that is the values, because here the torque comes in. So instead of force, here you have the net torque. Because Newton's second law, rotational version, tau equal I alpha, and you put that there, and you have these equations. But here you see that we take, and we can mark that because this one has the rotational acceleration, this. So that one as alpha, that also I take in the clockwise direction. But I apply the equation, usually the standard apply in the counterclockwise direction. That is the standard way. So that alpha also become minus, right? Because I apply the equation, this equation in the counterclockwise direction, not in the clockwise, the usually the standard. But of course, in the here also you notice that you usually apply the plus y direction, right? Not in the minus y. But if you like, you can apply it in the minus y direction also, right? In the downward direction. Uh, in rotation, the counterclockwise direction is usually considered the positive direction. So here you see the torque on the disk produced by the applied force on the disk, because the cord is wrapped around the disk, is minus RT, minus because it is in the counterclockwise direction, angle is 90 degrees. So R F is T sine 90. Remember, RF sine theta is the tau. So here you have only one torque. So tau is just one, no other torques acting on it. So minus RT becomes the torque. Because the sine 90 is, angle is 90 degrees, sine 90 becomes, here the momentum is the radius, here R, and T is the force applied. So the torque applied on the disk is minus RT. That is taking counterclockwise to be positive. So since it is in the clockwise direction, become negative, torque become negative. Same as like in the force, and alpha also become negative. Alpha, because I mark the alpha in the actual rotation direction, but we take usually in the counterclockwise to be the positive direction. And here the inertia I, for a disk is half mr squared. Minus minus cancel. And for the tension, I get this equation. So I can use that tension value in the first equation because I don't know what the tension is, and I can find what is the acceleration, right? But before doing that, I have to go from the that is rotational, from the rotational to translational, because alpha, I want to find the A, not the alpha first. So to find, the relationship between A and alpha, that is the translational variable, and the rotational variable is that is R times the rotational variable gives the translational variable. So A equal R alpha, but R is capital R. So when I put here instead of alpha, I put here R alpha, instead of R alpha, I can put A, R alpha A. So I get that. And I put that in the first equation, like that, like this. And I solve it for A. Now the only unknown variable is A here. And I solve, find A in terms of the known variables. So for the acceleration of this block, I get, that is the simple M, I get this value, and I can put the numbers and calculate what is that acceleration. And the next one, any questions there? So we did this several times, many times. There is a question. So one student is asking, I am suspecting if this guy is a student. So can the inertia be negative value? Yeah, like you mean like in the potential, right? Like the gravitational potential. So can someone answer that question? Can the inertia be negative value? Good question though. I mean, it is not a perfect question, but can the inertia be negative? Can someone tell? And also you have to tell why. You can look at the definition of inertia. Can anyone remember the definition of inertia? Sigma mi ri square. You can look up the note. M cannot be negative. R squared R square value cannot be negative. So inertia cannot be negative. Right? Yeah, when you think only, you will have the questions, but also you have to look up in the notes further and resolve that. So inertia cannot be negative. One student is asking, can inertia be? Unless you are doing particle physics or something, and you have negative energy and negative mass, and that's totally out of, yeah. And you are in a black hole and something like that. Yeah, totally hypothetical, right? Or you are going through a wormhole or something like that. This cannot be negative. And yeah, all right. And yes, part B of that question, the angular acceleration of the disk. So that's the alpha. So it's very easy. You just convert back to angular form from the linear form. You know, A equal R alpha. And so alpha equal A over R. And you get the angular acceleration. So first you find the linear acceleration, then you find the angular acceleration using the relationship between the angular variable and the linear variable. And part C, the tension in the chord. Tension. So tension, you remember that we found it as T half in A. So we already found the A, we know the M, you just put the numbers and find the tension. Any questions? No? So if you don't understand these things, I mean, there's something terribly wrong. You have to go back and do the A level or just leave the country. Just take the next flight and go to some country where you can really learn, do your A levels and O levels properly. Right? Everyone understands this, right? All right. Okay, I think we did a lot, and there are more questions. You can do I'll put this also on the LMS, all the answers. You can read it and come. And part two, question number 2 is actually, yeah, with two masses. Similar problem with two masses. So there will be two torques acting on the disk. You can read it and come next week or whenever we meet again, right? And yeah, there are some oscillation problems also. So I'll put this on LMS. So this week I will not put the tutorial immediately because on vectors, because we have to do some more stuff. Next week probably I can put it. All right. And due to the current situation, the quiz date also I am not immediately. Yeah, let's look at it also.
Recording stopped.
All right. So if you have any questions, you can ask me now. Yeah, you can read it and count. Next tutorial, probably I will give it next week on vectors. I have put all the notes, but you can read it and come also next week. So next week we can do the remaining part of the tutorial and also the remaining part of the uh, vector lectures. All right. There is some question. Yeah, the quiz. There is the thing. Currently, no one is able to tell that because of the current situations. But of course, I will let you know as soon as possible. Uh, because it's a quiz, I can give it anytime. but I don't know what is the situation. So, but we have like 4 weeks, can do anything. I can give even 2 or 3 quizzes more if you like. So I think no worries there. But be prepared. Look at tutorial this discussion for tutorial discussion for tutorial 5 discussion, and so that's the next one, right? For the quiz number 3, and also maybe tutorial 6 discussion. We all now completed that also. Uh, right? Be prepared because quizzes are just quizzes. You should be prepared at any time. Because this is university, so it's up to you to like be prepared and at any time, because this is actually this professional degree. It's supposed to be. So it is like medicine, engineering. It is engineering. It is the brother of engineering, technology. So it's a professional degree like medicine. Doctors do medicine. Technologists do technology. Engineering technologists do engineering technology. And engineers do their engineering. So you have to work hard and learn the stuff. And at least if you don't know the fundamentals and you are calling yourself a professional, that would be the joke of the century, right? But in Sri Lanka, of course, that could definitely happen because many jokes are going on everywhere from the beginning of the land, right? But at least try to become some professionals. All right, I will stop now. Any questions you can ask? Still, 1 or 2 minutes, I will stop. ඉතින් දුවවත් යවනවලු සල්ලි යන්න. ඊළඟ ඉස්කෝලේ මත් යනවා නේද? ඊට පස්සේ ඉස්කෝලෙන් අයින් කළා.